Alright, so we are going to work out the Unit 6 review. The first section is asking to tell whether or not the ordered pair is a solution to these lines. So what you're going to do is plug in, wherever there's an x, you're going to plug in 8, and wherever there's a y, you're going to plug in 5, and you're going to tell whether or not the statement is true. 9 times 8 plus 7 times 5 equals 8. We know 9 times 8 is 72, plus 7 times 5 is 35, equals 8. And then I figure out the math and tell whether or not the statement is true. 72 plus 35 is 107. Does 107 equal 8? No. So that's not a solution. This point is not a solution to those two lines. It has to be true for both systems in order to be a solution. It's not true for one, so I can say it's not true for both. Go on to the next problem. This is my x and this is my y. I plug in and tell whether or not it's true. Nine times a negative 3 is a negative 27, plus 7 times 5 is 35, equals 8. Negative 27 plus 35 is 8. 8 equals 8, that's true. So I test my next line by doing the same thing. 8 times a negative 3 minus 9 times 5, see if that equals a negative 69. 8 times a negative 3 is negative 24. Negative 9 times 5 is a negative 45. Negative 24 minus 45 is going to be a negative 69. That equals negative 69. So it's true. Because it's true for both equations, it's going to be true for the entire thing. So yes, negative 3 comma 5 is a solution. Number 3, give the ordered pair that is the solution for the linear system. We know the solution to a linear system is where they intersect. So that point right there where those two lines cross is my solution. That coordinate point is negative 3, because you go left 3, and then positive 6, because you go up 6 in order to get there. Keep in mind, you always want to write your solutions in coordinate point form. The next section is graphing two lines, and you have to tell whether or not there's a solution. We know the solution is going to be wherever they cross, and then we're going to write our solution in coordinate point. My first step is to always make sure that my lines are in the form of y equals mx plus b, where m is your slope and b is your y-intercept. So I'm going to start with my first line here. Y-intercept is positive 3, so that's where I start. And then my direction is that 4 right there. Tells me to go up 4 and right 1. Up 4, right 1. Up 4, right 1. From here, if I wanted to work backwards, I could see, how do I get from this point back to my original? Well, I go down 4, left 1. So I repeat that process. Down 4, left 1. Down 4, left 1. And I can continue that process the entire way. Make sure you connect your dots for your line. And you want to try and extend that line all the way through the graph. Then you graph your next line. I know my y-intercept is going to be a negative 2. So that's where I start my line. And then my slope tells me to go down 1, right 1. Because there's that imaginary 1 right there. Down 1, right 1. Down 1, right 1. When you extend your line backwards, it intersects on the graph at your solution. In this case, it would be negative 1, negative 1. solution by graphing. You would do the same thing for problem number 5 and problem number 6. So problem number 6 is a little different because it's not in y equals form yet, so I need to get there first. In order to solve for y equals, you need to subtract 2x from the first one, and whatever you do to one side, you have to do the other. So you get y equals a negative 2x plus 2 for your first equation. And then for your second equation, in order to move this 2x over, you do the opposite, which is addition. So you add 2x to both sides. So this equation would be 2x minus 2. Now I can graph both of these lines. My first line, I'm going to start at positive 2 on my graph, and then my slope is down 2, right 1. So you go down 2, right 1, and extend that line all the way down. Connect your dots. Then you do the same thing for the next line. My y-intercept is at negative 2, so that's where I start on my graph. Then my direction is positive 2, so I go up 2 and then right 1. And I connect my dots. Where these lines intersect is your solution to the equation, which should be right here at 0, 1. Problems 7 and 8 are asking you to do that same thing, but instead of solving by graphing, you're going to be solving by substitution. So what you want to do is make sure that you have, get my work out of the way there, that you have one of the variables solved for first. Then, since x is already solved for, you take this section right here, y minus 3, and you plug it into the opposite equation where there's an x. So I'm going to rewrite my first equation, and instead of writing that x, I'm going to write what x equals. So instead of writing that x, I insert those parentheses, y minus 3. Now I can solve for y by distributing. 4 times y is 4y. 4 times a negative 3 is a negative 12. And then continue writing the rest of your equation. I notice that I've got like terms on the same side of the equal sign, so I can combine these guys. Sorry, that makes it kind of difficult to see. But 4y plus 3y is 7y, and I still have that negative 12 equals a negative 5. From here, I want to get my whole numbers to the right side of the equation, so I add 12 to cancel them out. Whatever I do to one side, I have to do to the other. Negative 5 plus 12 is positive 7. And then from there, you want to get y by itself, so you do the opposite of 7y, which is divide by 7. It cancels. 7 divided by 7 is 1. So that's my first section of my coordinate point. But now I need to solve for the x variable. So what you do is you take this y that you just solved for, and you plug him back in to the most simple equation here. The most simple equation is that x equals y minus 3. And instead of writing y, I get to write the number 1 because I know y equals 1. And then I do the math. 1 minus 3 is a negative 2. So x equals a negative 2. I've got my x and my y, so my coordinate point is complete. That coordinate point, that solution, is going to be negative 2, 1. And that is your answer. Problem number 8 will be similar. You just have to make sure you get x by itself first. It's the easiest to get by itself because he's almost there. We just need to move this 4y to the right in order to solve for x. You would do that by subtracting 4y from both sides. So x equals negative 4y minus 1. Once you get that letter by itself, you can take this and insert it into that opposite equation where the x is. And you would rewrite 2 times negative 4y minus 1 minus 5y equals 11. From here, you need to simplify by distributing. 2 times a negative 4y is a negative 8y. 2 times a negative 1 is a negative 2 minus 5y equals 11. I notice I've got like terms on the same side of the equal sign, so I go ahead and combine those first. Negative 8 minus 5 is going to be a negative 13. Y minus 2 equals 11. I want to get the whole numbers to the right side of the equation, so I do the opposite of a negative 2 to cancel him out. You get 13 equals negative 13y. From here, I want to get y by itself, so I divide by a negative 13. And it cancels. You divide by a negative 13 on this side. So y equals a negative 1. Awesome. Almost there. I just need to go back and plug in to my most simple equation right there. Instead of writing y here, I get to write a negative 1. So I'm going to rewrite my equation up here for a little bit more room. Negative 4 times a negative 1 is a positive 4. Positive 4 minus 1 is a positive 3. So x equals 3. So my coordinate point is 3, comma, negative 1. Coordinate point should have parentheses. Okay? Solving by elimination is the next section. It's similar to substitution, but a little bit better because we get to eliminate one of those variables. If you look at problem number 9, I notice that I have a negative y and a positive y. I can cancel both of those out when I combine these two equations because they're exactly opposite. And then I combine my equation. 3x plus 2x is going to equal 9 plus 1. Notice you're just taking these two and adding them together on the left side because they're on the left side. Then you're taking these two, adding them together, and putting them on the right side of the equal sign because they're on the right side of the equal sign. 3x plus 2x is 5x equals 9 plus 1 is 10. And then you would divide by 5, divide by 5. So x is going to equal 2. Just like in substitution, now that I'm done with one of the variables, I take it and I plug it back into the most simple equation. I like the second equation, 2x plus y equals 1, because the numbers are pretty simple. So what I'm going to do is take that 2 and plug it in for the x. 2 times 2 plus y equals 1. And then I'm going to solve for y. 2 times 2 is 4 plus y equals 1. In order to get y by itself, I have to subtract 4. Cancels, minus 4 from here. Y is left on the left. 1 minus 4 is a negative 3. I've got an x and I've got a y, so I've got my coordinate point. 2, comma, negative 3. That is my solution. Sometimes on your elimination, though, you're not going to see the elimination right away. You might need to multiply one of the equations in order to eliminate easier. So for number 10, if you notice, you've got a positive 7y here and a negative 14y here. So if you multiplied the top equation by 2, then you would have a positive 14y, and that would be able to cancel. So I'm going to multiply each piece by 2. 2 times 5x is 10x. 2 times positive 7y is a positive 14y equals 2 times 10 is 20. Notice now these two cancel, and I can combine these x's and put them on the left side of the equal sign. And then I can combine these two whole numbers and put them on the right. 6 plus 20. I can continue solving for x. 13x equals 26. Divide both sides by 13. So x is going to equal 2. Once you have your x variable, you go back and plug it into the most simple equation. I like the second one, 3x minus 14y equals 6. So I take that 2 and I plug him in for the x. 3 times, we'll make those parentheses, 3 times 2 minus 14y equals 6. 3 times 2 is 6, minus 14y equals 6. Subtract 6 from both sides. You get a negative 14y equals 0. And then you would divide both sides by a negative 14. 0 divided by any number is just 0, so y equals 0. So your coordinate point here is 2, 0. Numbers 11, 12, and 13 are also solving by elimination, just like what we just did. So I'm going to skip to number 14. It's just asking what the solution is to this linear system. If you notice, the best way to solve this is going to be by elimination, because you already have a positive 3y and a negative 3y. So let's go ahead and cancel those out and combine those equations. 5x plus 4x is 9x. 22 plus a negative 4 is 18. To solve for x, you would divide by 9 on both sides. So x is going to equal 2. From there, just like normal, I'm going to plug it into the most simple equation to solve for y. I'm going to plug it into the 4x. So you get 4 times 2 minus 3y equals a negative 4. Pull it into the light a little bit. 4 times 2 is 8, minus 3y equals a negative 4. You would subtract 8 from both sides. You get negative 3y equals a negative 12. And then you would divide by negative 3 on both sides. Cancels, and you get y equals positive 4. So the solution to those two equations is 2, 4. The last section I'm going to work is number 16. That is a review from last unit. It's asking us to write the equation of a line in slope-intercept form that goes through this point, 1, negative 2, and is parallel to this equation. If you remember, parallel means same slope, so my slope is going to be 1/2. If you have a point and you have a slope, then you want to use point-slope form, which is y minus y1 equals m times x minus x1. That's my point-slope form. Here's my point, and so I just plug in what I know. Y minus y1 is a negative 2. I know that minus a negative 2 turns into plus a positive. Then I've got 1/2 for my slope, x minus x1, which is going to be 1. From here, in order to solve, I want to distribute. You get y plus 2 equals 1/2 x minus 1/2. Then I solve for y by subtracting 2 on both sides. Minus 2 and it cancels, minus 2 over here. Y is going to equal 1/2 x minus 2.5, or 2.5. So that's my equation in slope-intercept form of a parallel line to the one given. I kept the slope the same, and I made it go through this point. Number 17 is very similar, just asking you to write it as a perpendicular line. And if you remember, perpendicular means I need to flip the fraction and change the sign of the slope. So my new slope, instead of being 1/2, it's going to be 2/1, or just 2. And instead of being positive, this time it's going to be a negative. So my new slope is negative 2. I have the same point, x and y, So I plug it into my point slope equation, just like I did on the last problem. Y minus y1 equals m times x minus x1. Notice the only thing that's changed is the slope here. So I distribute. You get negative 2x plus 2 equals y plus 2. In order to solve for y equals, I subtract 2 on both sides. You get y equals a negative 2x, and then positive 2 minus 2 is just 0. So this is my equation. Number 18 is asking for both of those equations in standard form. So my first equation was y equals 1/2 x minus 2.5. My second equation is y equals a negative 2x. In standard form, all you want to do is take these x's to the other side of the equation and make sure that they are whole and that they are positive. So in order to move these guys to the left, I need to cancel them out by doing minus 1/2 x, and it cancels. And whatever you do to one side, you have to do to the other. I know y is positive, so I add a plus sign right there, and I get negative 1/2 x plus y equals a negative 2.5. From here, I look at the number in front of the x, and I see, is he whole? No, he's not. Is he positive? No, he's not. So I have to change it by distributing a number throughout the entire equation. The way I choose that number is by looking at the denominator. I know I'm going to multiply by him to make him whole. And then if it's a negative, I multiply by a negative to make it positive. So I'm going to multiply each piece by a negative 2. Negative 2 times a negative 1/2 is just positive 1x. Negative 2 times positive y is a negative 2y equals, and then a negative 2 times a negative 2.5 is positive 5. And I'm finished. The number in front of the x is whole and positive, so I've written it in standard form. For my next equation, to write it in standard form, I want to do the same process. Make sure this guy comes to the right. I'm going to cancel him out by adding 2x to both sides. Cancels over here, and I add 2x over here. I can rewrite my equation as positive 2x plus y equals, and then what's left over here? Nothing, it's just a 0. From there, I check to see if this guy right next to the x is whole, and he is, and positive, and he is. So I'm done. This is my equation in standard form. Okay, well that's it for Unit 6 review. If you have any questions, please feel free to shoot me an email or ask in class. I hope that helped you guys, and I'll see you soon.